There's two laws that we have to talk about besides the power law. The product law tells us that the log base b of x plus the log base b of y is equal to the log base b of x, y. Of course, b has to be greater than 0, b cannot be 1, and x and y have to be greater than 0. Because remember, the argument of a log must be 0. Sorry, it must be greater than 0. It has to be positive. So you got the product law, and you've got the quotient law, which says the log base b of x minus the log base b of y is equal to the log base b of x over y. Subject to the same conditions as before. B has to be greater than 0, b cannot be 1, x has to be greater than 0, y has to be greater than 0. And to see how these apply, we're going to work through page 384. Basically 1 to 10, just not 8. Number 1. They want us to simplify using the laws of logs. This is just going to be the log of 9 times 6. So the log of 54. Now, to save some time, you'll notice that in question 2 it says use a calculator to evaluate correct to 3 decimal places. So I'm just going to do that at the same time. The log of 54 correct to 3 decimal places is 1.732. It should be a familiar number. Log 48 minus log 6. And you notice they don't specify the base there, meaning that it's a common log. 48 and 6 are both positive and none of them is 0. The base is 10. 48 divided by 6 is 8. So that's going to be log of 8. Correct to 3 decimal places, that's going to be 0.903. Log base 3 of 7 plus log base 3 of 3, that's going to be log base 3 of 7 times 3, or log base 3 of 21. Now, to evaluate this, we're going to have to use the change of base formula on our calculator, and we're going to evaluate that on our calculator by doing log base 21 divided by common log of 21 divided by common log of 3. And correct to 3 decimal places, that's going to be 2.771. So log base 5 of 36 minus log base 5 of 18 is going to be log base 5 of 36 divided by 18, which is the same as log base 5 of 2. And to evaluate that, again, you can use your change of base formula. Log base 5 of 2 is the same as log base 10 of 2 divided by log base 10 of 5. On your trusty calculator, log base 10 of 2 divided by log base 10 of 5 is going to give us 0.431. So 4a says log base 6 of 18 plus log base 6 of 2. That's the same as log base 6 of 18 times 2. That's going to give us log base 6. 18 times 2 is 36. 36 can be written as 6 squared. And using our power law, we can say that's 2 times log base 6 of 6. Now this part is 1. So that's equal to 2. So the next one is log 40 plus log 2.5. That's the same as log of 40 times 2.5, which is the same as log of 100. But 100 is nothing but 10 squared. 2 comes down, you've got log, common log of 10 is just 1. So this is going to be log base 12 of 8 times 2 times 9, which is the same as log base 12. 8 times 2 is 16. 16 times 9 is 144. But 144 is nothing but 12 squared in disguise. 2 comes down, log base 12 of 12. Now this bad boy is just 1, and I know you're shocked. The answer is 2. So this is going to be the same as log 5 times 40 times 5. 5 times 40 is 200. 200 times 5 is 1,000. So that's the same as the log of 1,000, which is the same as the log of 10 cubed. which becomes 3 times the common log of 10. This is 1. And so our answer is 3. So this is going to be log base 3 of 54 divided by 2. Log base 3, 54 divided by 2 is 27. That's the same as 3 cubed. That comes down in front. The log base 3 of 3 is 1. Log 50,000 minus log 5. That's the same as log 50,000 divided by 5. Log 10,000. Log of 10 to the 4. 4 comes down. Common log of 10 is 1. It's not 2 or 3, it's 4. So that's going to be the same as log base 4 of 320 divided by 5. 320 divided by 5. 5 goes into 36 times and goes into 24 times. That's the same as log base 4 of 4 cubed. This is 1.